Hi everyone student, now we need to start our lesson. That's a 4.4. I think I left about the structure question only. So make sure you take out your paper, then we check together for the structure question. So we start with the question 12. Okay, let's see the question 12. The diagram they show about the arrangement of the apparatus, which is used by the student. They want to determine the relationship between the pressure and also the volume. So pressure and volume support is a Boyle's law. So from here, we go to highlight first what they want. Okay, they want to pressure and also the volume of the gas, constant temperature. So this one is a Boyle's law. Let's see the diagram. We got syringe and also the Barden gauge. So what will happen to the reading of the Barden gauge if the piston you push forward? You push forward means the volume become less already. So the answer should be the pressure will also increase. When your volume decreases, the pressure will be increased. So from here, the reading of the Barden gauge increase. Okay, let's see the second one. The law involved to determine the relationship between the pressure and also volume. So from here, we find it there a constant temperature. So what's the name for this law? The law is a Boyle's law. Okay. Okay, let's see the next one. You need to sketch about the graph against pressure against the volume. So from here, you need to plot if pressure straightforward against the volume, you find it, you plot the graph is inversely proportional. So another one, we also can plot pressure against 1 over V. When pressure against 1 over V, you find it, the graph will become directly proportional. So both of the graph also can be accepted. Okay, this one, first one, inversely proportional. Okay, this one is the second one, directly proportional, but you need to invert it. Okay, you need to invert your V. Your volume must be 1 over V. Okay, question D, there's a calculation. The student that obtained the pressure of the gas is 1.12 times 10 power 5 Pascal. Okay, when the volume of the stream is 45 cm cube. Okay, calculate the pressure of the gas when the volume of the stream becomes 30. So that means we're using a formula P1 V1 equal P2 V2. Okay, let's see the calculation. Okay, so from here, this one is a P1, V1. This one is a V1, 45. So your P1 is 1.15 times 10 power 5. Okay, this one is your volume 2. Then the P2 we do know. After apply all the thing, we get it. The answer is 1.68 times 10 power 5 Pascal. So please check your answer, is it correct or not? If not, you do some correction. Okay, let's see the question 13. Okay, the diagram that show the manometer is connected to the gas tank. Okay, let's see the gas tank. Okay, now when starting the clip is clipped together, that means they will separate. So after that, when the clip just open, you find the position of the mercury, then it changes. Let's see the level X. Level X is higher, level Y is lower. So from here, the label level X is 45. Level Y is 20 cm. Okay. Now the temperature of the gas 127. So this one situation, the temperature is 127. So from here we assume atmospheric pressure is 75. The question is provided. Okay, first one they ask you to determine the pressure at the point X. Okay, let's see the point X. Above the point X we got what? We just got atmospheric pressure, is it? So from here the pressure at the X is the atmospheric pressure. So from here, we just read from the question. Atmospheric pressure is how many? 75 cm mercury. So this one is the answer. Now we go to the second one. Okay, now you need to determine the pressure of the gas in the tank. Okay, in the gas tank, here the pressure is how many? So from here, we need to using the same level, same pressure. Okay, remember, I think you never learn. This one is a Form 5 syllabus. So I need to explain again. When the level, liquid level becomes same level, the pressure will produce the same. So from here, we're going to see the Y. Y is the same level with 20. So from here, we need to read above from this point. Okay, this point, I read from the 45 until 20. Actually, here is the difference how many? 45 minus 20, I get it, there's 25, is it? Okay, so from here, the difference is 25. So I label first. Wait, I go right first. This one is 45. Okay, I'm using the red color. Sorry. This one is a 45. This one is a 20. So the minus, after I go to differences, I get it here is a 25. So from here, the difference is a 25. Means what is the pressure at the point Y? Okay, the pressure of the point Y same like this point. Okay, same level, same pressure. So I can say, okay, now I label this one as a Q. So pressure at the Q is how many? Pressure at the Q is a 25 cm mercury. Okay, don't forget you got one more at the top. Top is the atmospheric pressure. So I need to add atmospheric pressure. There's a 75, is it? Just now from the question. Cm mercury. So this one is the total pressure at the Q. So if I find the Q pressure is how many, then I know the Y pressure is how many. So from here, I show you the readings. 75 plus 25. So from here, I get it, the answer is 100 cm mercury at the point Y. Okay, that means the pressure gas. Because at the Y, we just got gas pressure only. We don't have any atmospheric. Okay, then we go B. When the gas is cooled to the T degrees Celsius, the mercury level Y increasing and the X decreasing. So that means the situation is, now the situation is when you cool down, okay, you cool down, this one is go to the gas, is it? So two level become the same. Okay, when you cool down, that means the two level become the same. Okay, we don't have any higher or lower. So that means this one X, this one Y already. So same level, same pressure. So from here we get it. Same level. Okay, based on the kinetic theory of the gases, explain why the mercury level X decreases when the gas is cooled down. Okay, when the X is cooled down. So when the gas cool down, you must think about the temperature drop. When the temperature drop means the kinetic energy also will be drop. Is it? So kinetic energy drop, that means the molecule how to move. The movement will become slow down. Okay, when the movement becomes slow down, that means the collision. The collision between the molecule and the collision between the container, they will drop. Okay, from this one situation, we find it, the pressure, they will automatic drop. Okay, so from here, let's see the explanation for kinetic theory. Okay, so the first part, okay, we're going to highlight. As temperature of the gas just cool down, kinetic energy of the gas molecule decreases. Okay, after that, you must say collision. The frequency of the collision between the gas and molecule and also the tank container also decreases. Because of this one, finally, the gas pressure drop. Higher atmospheric pressure, okay, atmospheric pressure is the outside one. Higher atmospheric pressure than at the X, they will compress. Because your inside become drop pressure, that means the atmospheric pressure automatically will higher than inside pressure. So they will compress the mercury. Okay, until where? Until the level X, they finally together with the Y at the same level. So they will compress the mercury level X, and finally the both column of the mercury become the same level. So this one is an explanation for the kinetic theory. Okay, now they ask you what is the pressure of the gas at T degrees Celsius. So we don't know T degrees Celsius is how many. So from here we need to do the calculation. Okay, let's see before that the info. Okay, before that they got info to tell you. Okay, for this one we need to using what pressure law formula, is it? Okay, let's see the pressure law. So I write first. Okay, pressure law is a P1 over T1, P2 over T2. So from here, the first one, we need to know the P1 first. Okay, P1. First one, the P1 from the question, we get it as a 100 Pascal, is it? Okay, we do the calculation already. You can refer the question 2, A2. When the gas tank, they ask you what's the pressure. We find it, the gas tank is 100. That's a P1, 100. Okay, then after that, we know the temperature is how many. Okay, refer your question, the temperature is 127. Okay, suppose I told you already temperature for the gas law, we must using absolute, is it? So this one is a 127 plus 273. Okay, then equal P2. Okay, P2 is the situation when the X, the mercury level at the top. Okay, that means I draw again the just now diagram. So this one is a just now diagram. Okay, the tube is closer. Wait, sorry. Uh, so I go to erase first. I go to redraw. Okay, so this one is the tube. Tube go to the gas. Okay, this one is your gas. Okay, after that, this one is a tube. The tube is closer. Okay, after that, this one go here. Sorry, my drawing memang like this one. Okay, because I'm using the pen, very hard to draw. Okay, I draw properly. Okay, so from here. Okay, wait. Okay, come down. Okay, this one join the tube. Okay, go here. Okay, so from here, the first diagram, you see this part is a X, is it? Then this part is a Y. This part is a Y. So this one is the first diagram. So that means we need to know the two situations. First situation is here. Okay, so from here, the first situation, we know there's a P1 is a 75 atmospheric pressure, is it? Okay, so here is where the gas, we know the pressure is 100. So from here, P1, I think there's 100. Okay, after that, we know the Y pressure, is it? So this one is the first case. Okay, the second case is when the temperature drop. That means you cool down. Okay, you cool down the gas. Okay, you cool down the gas. This one is a gas. Okay, so from here, when you cool down the gas, they say become constant already. The level become the same. So the level become the same. We know this one is a atmospheric pressure, is it? Because you come down already. Up is open. So same level, same pressure means this part also is a gas pressure. You also can say the same like the atmospheric pressure. The meaning should be the same. So this one we call case 2. Okay, case 2, so you need to put in Case 1, I know already, 100 over 127 plus 273. Okay, case 2, I know the pressure 2 is a 75 atmospheric pressure, but T2, I don't know. So from here, you need to find the T2. Okay, let's see the answer for T2. Okay, guess at the T2. Okay, I think this one got any, yeah, sorry, this one is a question the following. So from here, what is the pressure of the gas at the T? So pressure at the T, we know lah, this is a T2 already, there's a 72.5. Okay, when T, okay, this one temperature, that means when the gas temperature, this one is a drop temperature. When this one temperature drop already, they ask you what is the pressure. So this one I show you already. This one is when the temperature drop, they will drop until same level. So now the pressure is 75 cm mercury. Okay, now we do the calculation. This one calculation I need to bring down. Okay, this one is a calculation here. So from here, okay, P1 over T1, P2 over T2. So 100 over 400. This one become 400. Okay, 75 over T2. So I get the T2 is a 300 Kelvin. Final answer must in degrees Celsius. So from here, I get it 27 degrees Celsius. Okay, so from here, what law we involve? This one is a pressure and temperature, is it? So another thing is a volume constant. So from here, we're talking this one is a pressure law. Okay. Okay, next, question 14. Okay, let's see the keyword from the question 14. Okay, they say the balloon. Okay, the balloon, there's a type fastened to the open end of the test tube mouth of the balloon before and after the test tube is heated. So when you see the diagram 2, air trapped inside the capillary tube, this one. Okay, also put inside the air trap, there's a sulfuric acid index. Okay, below that is a trap A. Okay, after that they say they also heated. You see the second diagram, they're heated. So actually the two diagram also mention the same thing. When starting, the balloon is a smaller size. When I heat it, can you see the sign become bigger? So this one stands for what? This one stands for volume. Trap A also said, before I heated, the volume less. When I just heat it, you find it the volume increasing. So this one is a temperature and volume. This one is an observation. What you can observe from here, state one similarity. Okay, the similarity is okay, volume of the A in the balloon and also capillary tube increases when the temperature increase. So this one is a both similarity from these two diagrams. Okay, now we need to compare. Compare the mass of the A in the figure A and also figure B. So the mass of the A, the figure A and figure B means what? You need to compare together, balloon and balloon. Then the capillary tube is capillary tube. We cannot compare balloon and capillary tube. It's a different things. So if I compare the figure 1A and 1B, suppose the mass is unchanged. Okay, mass always constant. Okay, so from here the mass of the A in the both figure actually is constant. Okay, now we based on the observation in the A1. Okay, comparison in the A2, give a relationship between the physical quantities. So we're talking about the A1 and also the A2. Okay, give the relationship. Okay, let's see the relationship. As the temperature increase, volume of the trap air also increase. Then you need to relate with the A2. A2 is what? A2 is a mass. So you need to mention the mass of the trap air constant. Okay, relate with the one. Is it one is what? Temperature and volume. Then after that you need to including the A2. So A2 is a mass. So from here you need to mention three physical quantities together. Volume, temperature, last one you say the mass must be constant. Okay, now we're going to mention this law is what? Volume and temperature. So suppose it's a Charles law. Okay, based on kinetic theory again of the gas, you need to explain how come this law will occur. So again, temperature increases. So temperature increase, you must talking about kinetic energy. When the kinetic energy increase, after that collision, okay, the frequency of the collision between the molecule and wall container also increase. Okay, because of the volume can be expanded. Okay, the whole situation, the volume can be expanded. Okay, expand until when? Until the pressure become constant, then they will stop. So this one situation you must mention, the pressure is constant, although you are heated. Okay, let's see the answer. Okay, again, as the temperature increase, air molecule move faster and increase kinetic energy. Okay, collision between the A molecule and the wall container increases. Okay, last one is a different. With the constant pressure, the gas molecule will expand and increase the gas volume. Okay, the volume can be expand until until the pressure of the gas become constant. So the volume will until there they will stop. Okay, so this one is the answer for kinetic theory for Charles' law. Okay, so we finish our chapter 4.4, all the tutorial questions. We got one of the 15. You can see your 15, you got one of the experiment. Okay, so we just discussed a little bit about the diagram for the question 15. Okay, you see the aquarium. Okay, inside the aquarium, we got A bubble, is it? The A bubble at the deep sea, that's a smaller. After that, go to higher part, that means the surface of the water, the bubble become bigger. So this one is a relationship between the pressure and also volume. So this one actually is a Boyle's law experiment. Okay, but this one is not related for your syllabus because you don't have paper 3. Maybe you do the practical. So this one you also can refer in front because your notes also got Boyle's law experiment. So you can refer that. There's a syringe together with the Barden gauge. So that one is an experiment for the Boyle's law. Okay, so that means I never discussed about this one. You can refer back your notes. So I want to go is a chapter 5. Okay, this one is a new topic. Chapter 5, fundamental of the wave. So we're talking about type of the wave in this whole topic. Okay, first one, wave can be produced by oscillating or a vibrating system. Something oscillate, something vibrate, they also can produce a wave. For example, oscillating of the iron bulb on the water. Okay, let's see this one diagram. So the spring they hold together with the bulb. Okay, now let the spring to oscillate. When the spring just oscillate, the bulb will touching the surface of the water. So from here they will produce a water wave. Example like this. Okay, example I show you this one example is when you drop something on the water, you find it produce a wave. The circle one go outside, that one is a water wave. Okay, let's see the diagram here. Vibration of the tuning fork. Okay, this one is a tuning fork. Okay, when you just hit the tuning fork, they will produce a sound wave. So they will vibrate. Okay, two of the bar of the tuning fork, they will vibrate and produce the sound wave. So oscillation and vibration are the repetitive. There's a one of the motion repeated. Example, this one is the oscillation. You see the pendulum, when you just move the pendulum, they will oscillate left and right. So this one is a repeat motion. Another one is a vibration. Vibration example for the spring. You hold together with the weight, a load. So you go to move the spring. So you find it the spring will oscillate up and also down. Okay, so this one we call vibration. This one we call oscillation. Okay, what is wave? Now we're going to see the definition for the wave. Wave is produced by the source of vibration. Okay, from the source of vibration. As the wave travels from the medium, there is no transfer method, but only transfer the energy from the vibrating source. So that means when the wave just move, okay, anything just above the medium, they never travel together. They're just an object. Okay, example, let's see here. To generate the idea, the wave just transfer energy without transfer the matter, we're using the slinky spring. So this one is a slinky spring. So can you see the ribbon here? The ribbon they tied together with the spring. Okay, now they say let two people they hold each end of the slinky spring. Okay, end of the A and end of the B. Okay, two students will hold it. Okay, move the end of the A of the single spring from the side to side. B fixed. That means the student B, you never move anything. Just the A go to shake up and down. So observe the movement of the wave along the single spring and the movement of the ribbon. So you'll find it, the spring like moving, but actually no moving because you hold it, is it? So we find it, they are the direction like this. They want to go this direction. Okay, when you just shake, you find it they want to go to right hand side direction. But the ribbon, how? The ribbon just move up and also move down. The ribbon is cannot move one. Okay, the ribbon now stand for object. That's the medium. Okay, they never transfer the metal lah. So from here the direction stand for direction for the energy to transfer. So from here this one is a one thing to explain what is the wave. So the wave just transfer the matter, just transfer the energy, never transfer the matter. Okay, now we're going to see when you shake. So when you shake about the stinky spring, so you find it direction of the transfer. So direction of the transfer means they go to one direction. Okay, after that, you see the ribbon. The ribbon movement just up and also down. So from here they explain, movement of the wave from the end of the A to B, transfer energy from A to the B. Okay, the ribbon only vibrate in the fixed position. So the ribbon does not move in the direction which is the energy is transferred by the wave. So that means the ribbon never follow the energy transfer together. They just move at the same location but up and also down. Okay, now we're going to see the some example for the wave. Okay, wave can be classified as the mechanical wave and also electromagnetic wave. We got two types. Okay, mechanical wave means the wave, they need the medium to travel. Okay, travel we using propagate. The meaning for propagate means travel. Okay, example is a water wave, sound wave, shock wave as an earthquake, and also the wave in the spring and the rod. So this all is the mechanical wave because they need the medium to travel. Example is a example for the sound wave. What medium they need? There's a air molecule. If no air molecule, example is a vacuum. Actually, you cannot listen the sound. So the sound wave, they need the medium to travel. Okay, the second one we call electromagnetic wave. Electromagnetic wave means do not need the medium. Okay, although you are vacuum, they still can travel. Okay, example, we got radio wave, we got light wave. Okay, normal light wave, we got infrared, we got ultraviolet. This all is no need the medium, but they also can be travel. Okay, so mechanical wave and also electromagnetic wave. Okay, now we go to more detail about the mechanical wave. Okay, first one they say require the medium to transfer energy from one point to another point. Okay, they make up of vibrating particle of a medium. Example, water wave and sound wave. Okay, electromagnetic wave does not require the medium to transfer energy. They make up of the oscillating electric and also magnetic field perpendicular to another. So that including two things, you got electric, you got magnetic field. After that must be perpendicular to each other. Example, we got radio wave, light wave, and gamma wave. Okay, this one is a stationary wave. You see what means of stationary wave? Stationary wave is produced when the two identical progressive wave moving in opposite direction. Example, you plug the guitar. Okay, you find it, the wave they will progressive moving in the opposite direction. After that, they collide with each other. Now we're going to see the diagram here. We got T1, T2, T3, T4, and T5, is it? Mean this one is at the same time they are moving, they are vibration. So a stationary there's a wave where the profile of the wave does not propagate with the time. I mean when the time is how many, they're not together, go together with the time. So you find it, T1, they move higher. When T2, they move lower. So T3, they move another direction. So this one is a situation for the stationary wave. Okay, let's see the example here. Okay, I try, let's see this one can on or not. Okay. Okay, this one is a one of the stationary wave. Can you see the stationary wave? At the same time, they produce the wave, two or three wave together, but the maximum point go highest part is a different. Okay, so that's why they say two identical progressive wave moving in opposite direction. At the same time, one up, one down. Okay, so they oscillate with one each other. Okay, can you see the movement? Okay, so that means at the same time, two identical the progressive wave, there's a moving in opposite direction and collide to each other. So this one situation we call it there's a stationary wave. Okay, they never move one. They just up, down like this only. Okay. Okay, now I need to introduce two more. There's a main of the type of the wave. There's a transverse and longitudinal. Okay, let's see what's a transverse. Okay, wave, there's an in direction of the vibration of the particle is perpendicular. So you can see the diagram here. Okay, now the direction movement is where? Go here, is it? Okay, vibration how? Vibration is up and down, is it? So vibration is up and down. So can you hear this one situation is 90 degree? So from here they say the wave which is direction of vibration particle. The particle vibration must perpendicular to the direction of the wave propagate. So this one we call transverse wave. Okay, means the vibration particle and the wave direction perpendicular. So we call it as a transverse wave. So from here you can see the particle. The particle is a red color one. They just up, down, and up, down. And how about the blue color? Blue color is go to right hand side. So from here you find it there's a perpendicular to each other. So this one we call transverse wave. So from the transverse wave, I need to introduce the first one is a crest. Okay, this one is a crest, means at the top. Okay, at the top one we call crest, at the down one we call trough. Okay, example we got water wave and electromagnetic wave. Okay, these two is a transverse wave. Okay, now we go to second one. That's a longitudinal wave. Okay, longitudinal wave is a situation. Okay, can you see the diagram here? Vibration how? Vibration just left right. Okay, motion how? Motion also go to right. So from here we can say the particle now is moved parallel with the direction. Okay, parallel. Just now is perpendicular, now it's parallel. So this one situation we call it as a longitudinal wave. So from here on to introduce is a compression and also rarefaction. Compression means they compress together. Okay, rarefaction means they far away each other. So this one we call compression and rarefaction. Okay, example, there's a sound wave. Okay, so from here I also want to show when this one situation they produce a compression or also rarefaction. So when they're closer, this one we call compression. When they're far away, this one we call rarefaction. So this one is an example of the A molecule. Okay, closer means they compress together. Far away means that it's a rarefaction. Okay, characteristic of the wave. Okay, we see the characteristic of the wave. How the propagate of the wave. Okay, when they're near to the surface of the water. So you find it they become, crest become bigger. The crest become higher, is it? Okay, so from here, from this one situation, we need to know the 5 things. First is the amplitude. After that, we got period. Period means the time taken, frequency, wavelength, and also the wave speed. Okay, the 5 thing later I will explain more clear about this whole thing. Okay, class, this one is a wavelength. Wavelength is the distance between two consecutive points which are vibrating on the phase. I think this one I will continue for the next lesson. So we continue tomorrow. So see you tomorrow.